In problem number 17, we're using Rolle's theorem, which is just a specific case of the mean value theorem. So remember in the last problem, we did the mean value theorem, and the mean value theorem states that if you have a function that's continuous, the slope between any 2 points, you must have a point within that that has the same slope as its derivative. So here, we're using Rolle's theorem, and the only difference about Rolle's theorem is the Rolle's theorem is exactly the same thing as the mean value theorem, except we know that the slope is 0. So in order to show how many, what values of c that satisfy Rolle's theorem, we need to check two things. First, is this function continuous? Well, it's made up of sines and cosines, so yes, it's definitely continuous. And the second thing we have to check is what's the slope between the endpoints. So just like we do in the mean value theorem, we'll figure out the slope between the endpoints here, which is f of 2 pi minus f of 0 over 2 pi minus 0. Now, in order to use Rolle's theorem, this slope has to be 0, which means we're really only just concerned if the numerator is 0, which means is this true? F of 0 equals f of 2 pi. Right? If that is true, then this numerator is 0, means our slope is 0. Well, we have sine and cosine only, and sine and cosine have a period of 2 pi. So 0 and 2 pi are the same number. So yes, that's definitely true. Therefore, the endpoints are equal, and we can use Rolle's theorem. So just like in mean value theorem now, once we get that slope, we take the derivative and set it equal to that slope. In this case, our slope is 0. So what's our derivative here? F prime of x is cosine x minus sine x by doing your derivative of sine and cosine. And we're setting that equal to this slope between the endpoints, which we've figured out is 0. So we just need to solve this equation. You can add sine over to get this to be sine x equals cosine x. You could probably start solving it right there, but let me just do one more step here. I could divide by cosine to get tan x equals 1. That might be easier to see. So the points on this curve that have derivative 0 are the ones that satisfy this equation. Tan x equals 1. So if we find those x's, those are the x values that give us a derivative of 0, a slope of the tangent line of 0. So where is tangent x equal to 1? Remember, all students take calculus. Tangent is positive in the first and third quadrants. So we know we're only looking in first and third because we want it to be a positive number. And tangent is 1 when your angle is pi over 4. So we need pi over 4 in the first and third quadrants. Well, pi over 4 in the first quadrant is pi over 4. Pi over 4 in the third quadrant would be pi plus pi over 4. So remember that if you have an angle here, in the third quadrant, I'll go to pi and then go the angle further. So we're going pi over 4 more than pi, which means we got 5 pi over 4. And those two numbers are the only two that are within 0 to 2 pi. So keep in mind, tangent of x equals 1. We actually have infinite number of answers. We could keep going. But we knew that our interval was only 0 to 2 pi, so these are the only two answers that are within that, and those are the two that satisfy Rolle's theorem.
The Teaching Center, UF's Learning Resource Center.